Right, this is a nice projectile motion question, requiring us to do a bit of suvat and a bit of backwards work. An arrow was fired horizontally from the top of the castle. It stuck into the ground below at the angle shown. Let's start with a double suvat. So I've got the horizontal and the vertical. SUVAT for each one. Okay. What do we know? Well, the vertical distance fallen is 5.94. That angle there seems to be a little bit of a mystery right now. And that's all we're given. We do know that, in fact, the initial velocity vertically was 0 because it was fired horizontally. And we do know the vertical acceleration. So we can work some things out. We might as well have a go at that. We could use v squared equals u squared plus 2as to work out the final vertical velocity. So I'm going to do that now. I'm just going to write it up here. U squared plus 2as. That's going to be u, which is 0. 2 times 9.81 times the height, 5.94. Okay. 2 times 9.81 times 5.94. Take the square root, and that gives me 10.80 for the vertical velocity when it hits the ground. And why not? Let's just get the time while we're there. There are different ways of doing this, but I suppose I could use the acceleration now, 9.81, and divide the change in velocity by the acceleration. So I'm going to do 10.8 divided by 9.81, and that gives me 1.101 seconds, which is the same for both. But the horizontal is still missing a lot. Now, here's the trick. That angle that we're given, that was made when the arrow stuck in the ground, and the direction it was moving at the time was a function of the two velocities that it was traveling at, the vertical VV and the horizontal VH. That is our angle, 35.73. And it looks like we've got an equation using tan of 35.73. That's the opposite, which is the vertical, 10.80 divided by our horizontal velocity. So now we can get the horizontal velocity, 10.80 divided by tan of 35.73. That's 15.01 for the horizontal velocity. And the horizontal acceleration is 0 anyway, so we've got 15.01 as the initial horizontal velocity. And then we can work out the distance simply by doing the velocity times the time. So 15.01 times 1.101, and that gives us 16.53 meters for the distance that the arrow traveled horizontally.